In this discussion, I'm going to go over the basics of insulation, so some different insulation types, and also we'll look at some images, infrared images, to help you understand how you can use an infrared camera to help detect missing insulation and some other issues. Okay, so um, insulation reduces heat transfer. Okay, that's it. Remember our second law of thermodynamics, one of the outcomes of that is that heat always flows from higher to lower temperatures. Right? So if you have insulation in between area with higher and lower temperature, like you do in these images, so this would be your unconditioned space up here and the conditioned space down below. You fill this in with insulation and it helps prevent heat from moving from one area to the other. Now, I'm recording this in the winter, and so in that case, we're trying to prevent heat from moving up from the conditioned space to the unconditioned space. We want to hold the heat in the summer, it's of course the opposite. So this is hot attic. If you've ever been up in an attic like this, it's very hot in the winter, excuse me, in the summer. And so you want to prevent heat from coming down through it. And so into the conditioned space that's cooler. And so that's what insulation does. This is blown in insulation. This is fiberglass batt insulation, but this is all done mostly through air pockets. Okay. And remember, I went over that slide earlier. That air pockets are what really make this all work because heat has trouble traveling through any material with a bunch of air pockets in it. So some basic kinds of insulation that you should know. Fiberglass batt, I'm sure you've seen this before, that comes in these big rolls. Um, the R value of that is, we'll call it around R3 per inch. It's not a good air barrier, right? It's loose, but it's cheap. So a good, value per square foot. Now we have loose fill. This can be cellulose or it can be um, fiberglass. Most of the time, you're going to use cellulose. So this is again not a good air barrier. You just like fill this in, and it just fills up with this loose fill stuff. It's actually chopped up newspapers with some chemicals on it to prevent it from being flammable. Um, and so that you just fill in. Again, there's a bunch of air pockets in there. It's cheap. It's pretty easy to install. You could do this by yourself. But not a good air barrier. This is probably the easiest to install, although it's kind of a pain to work with. This is also, you just need a machine to do this. You can see that guy filling in the machine with the machine here and just sort of slowly fill it up. And I posted a video in this week's reading to show you that. Dense pack insulation. So loose fill is about, we'll call it R3.5 per inch, give or take. So these are pretty equivalent in terms of their R value. Now, dense pack insulation, you actually take the same as loose fill, but you can see this is a big um, hose, and this is just a smaller hose. And what you do is you actually shove it up inside the cavity, and you sort of fill it up and go down. So you shoot it up, and it sticks together, and it packs in really densely in those stud cavities. And remember, we went over what the framing looks like, so you know there's cavities in here. And so that's where you just fill it in, and then you drill another hole, you fill that in, you drill another hole, fill that in, and so on. And you cap these holes and put the siding back on. So this is great because it's not only is it a good insulator, about R3 or 3 plus per inch, but it actually is a good air barrier and it's really good at sound attenuation. So if you have this on your exterior walls and you live in like a busy city street, it's really good at sort of absorbing that sound and making it a little more quiet inside the house. This takes a little more skill to apply, but those are the three of the major types of insulation that you see. This is fairly uncommon. And most of the time you're seeing bats or loose fill. Loose fill if it's in an attic space, and then bats if it's a wall or an attic space or wherever. So those are the major types of sort of that looser insulation. But dense pack, some people do it. And just so you know, you may see these values. Usually they're going to be R per inch. And so like if this is R3 per inch and you have 10 inches, that's going to be R30, right? So you got to know how thick it is. Right, so some foam board types and then vermiculite. So the major foam board types, we have polyisocyanurate, big fancy word there. Most of the time, people just call it polyiso. You can see here we have a foam, or excuse me, a foil facing on this foamy type of inside. This foam, this is the polyiso. It's a really good insulator, R7 per inch. So if you remember on the fiberglass and the cellulose and all that's like R3, 3.5 per inch. So this is twice as good of an insulator, but it does absorb water. You put this foil facing on it to help prevent, water from just going right in all the time, and also to prevent airflow. So it's a good air barrier, but you don't want it to get wet at all. So it's got to be dry. But that's your highest R value per inch of all the sort of common types. You can go down to any department store and buy polyiso. It's not a specialty. It's not specialty material. This you've probably seen before. Some people call it blue board. Now there's pink board. There's green board. And those different colors are the same thing. It's just a different company that makes it. So this is called extruded polystyrene or XPS. So XPS is what you normally see this labeled as. And this stuff is great. R5 per inch, so high insulating value. Good air barrier because it has this facing on the side. It is very water resistant, so this is great. So people will use this below on a foundation. Anything below grade should have XPS just because of the moisture potential. Um, and then and this is like moderately priced. It's not super expensive. This is expensive, but the most expensive of the foams. This is the second most expensive, and this is cheap. So EPS, expanded polystyrene. So remember, we have XPS and EPS. EPS it's styrofoam. Okay. So decent insulator, about R4 per inch. So it's the least insulating of these. It's not a good vapor barrier, right? So it sort of breathes. It does absorb water, but it is cheap, like dirt cheap. Um, it's not used a lot, but it is used in some construction, like structural insulated panel, if you're familiar with that. Which we could talk about class if you want to, but that's a advanced high efficiency framing where you have two boards and you have XPS or EPS goes in between and just cut the wall to exact shape. So it's really cool if you're into modern building and green design. You would want to look up structural insulated panels. Anyway, that's your EPS, which is just styrofoam. And then vermiculite, which is not foam board. Obviously, it looks like this. It's like the little sort of popcorn, smaller than popcorn. Um, so this is actually, believe it or not, a rock that you heat up and it expands. If you've ever bought pot soil for a potted plant, the little white things in it, that's vermiculite. Okay, and they put that in there because it's really good at absorbing water. But it's also a decent insulator. This is old way of insulating. They don't use this anymore. Just this is more of a public service announcement than anything. If you ever see that in a house, don't mess with it. Don't disturb it. You gotta get a professional to remove it because most of that's contaminated with asbestos. So very important to remember that most of that's contaminated with asbestos. All right, so those are our major foam boards: polyiso, XPS, EPS. Again, these are our footage. So some other stuff that you'll see pretty common, especially in modern framing and advanced framing, is the spray foam. So this is two-part spray foam, and you have these two chemicals that are separated, and then you have a gun. You can see that it comes in and combines here. So when these combine and hit the air, what they do is they expand and they form this foam, right? And so this is really great if you don't have much room. And if you're insulating a ceiling, for example, like a finished attic you see here, and you put spray foam here, and you're getting like solid R, depending if it's open or closed cell, there's different types, but you can get up to like R6, 6.5 per inch. So super duper insulating, almost as high as polyiso. But it's great because it's an air barrier, some of it's a water barrier. Um, you can apply it on vertical and horizontal surfaces, so you could just spray the heck out of the place and just insulate it. And it's good at sound attenuation. I mean, all that stuff. So it is useful. It's expensive. It's definitely toxic, as you can see. This person's wearing a full Tyvek suit. You don't want to get that stuff on you. The gases are not good. But once it solidifies, it's still off gases a little bit, but obviously you don't have to wear Tyvek after it cures. So that's your two-part spray foam. Um, I don't have an image of this, but there's also one-part spray foam. And that's the stuff you can just go down to a regular hardware store and there's that little can. Usually they sell what's called great stuff. And that's very similar, but you don't use it for big jobs like this. You use that just to spray, seal little small areas. Okay. So those are some of the major types of foam. So what do I expect? I don't expect you to know all these details, but I do expect you to know the difference between fiberglass bat and uh, blown in cellulose or blown in fiberglass, either one, and dense pack, what that is, and sort of the general usefulness of them. And then foam board, you should know that polyiso is the most insulating, but the most expensive, and something you don't use below ground. Whereas this is your XPS is very common, pretty cheap, and can get wet, and it's a good insulator. And then your EPS, you don't really use that, so I'm not too worried about it. But and the vermiculite, you should know that if you see it, you don't mess with it because it's probably contaminated with asbestos. You should know that two-part foam is a really good insulator, really useful because it's a good air barrier, it's a good water barrier, and you can use it on just about anything. So that's used quite a bit in advanced framing. Really good if you don't have a lot of space, like in these roof rafters, these rafter bays. Um, yeah, and so it's something that you can actually install this on your own, but I wouldn't necessarily recommend it. Okay. All right. So let me show you some images here just to give you a sense of how useful an infrared camera is. So this is a single story home. This is in Newark, Delaware. It's a ranch. It's a slab construction. So it's just concrete slab here. And this is a unconditioned crawl space. And then here's your conditioned space. All right. And so these are images from inside. And so one of the great things about an infrared camera is that you take a photo with a camera like this, and it takes a digital photograph at the same time. And so here is we're just looking at this. This is a wall, and this is a ceiling. And you'd look at it, and you wouldn't think really anything of it. It looks like a normal wall to me. Missing a little molding here, but then you look at the IR image of that exact same spot, and you see this, right? And so remember, above this is unconditioned space. I forgot to mention this is in the winter. It's really cold outside when I was taking these photos. So I took all these photos. Um, and so above the ceiling is the cold crawl space. And here you can see the IR image, really a lot colder here. So what's going on? We're missing insulation, right? So you would have no way of knowing it just by looking at this without an infrared camera. So that's the beauty of the infrared camera, right? It shows you that very, very clearly, right? And you can just replace that insulation. This is from the same house, pull downstairs. You can see here's the regular image. So pull downstairs up to the unconditioned crawl space. And here's the infrared image. So take a minute to see, to think what's happening here. It's obvious that there's some missing insulation here. It looks a little streaky. There may be some air leakage coming out as well, but certainly missing insulation. Now this is a little trickier. Um, they do make caps for this, like this, right? So it's something you buy in the store. There's something you can build on your own. They make these nylon caps too, but that's not a good insulator. So this is really what you want to do. You need foam. That's great, great. That looks to me to be EPS, so that looks like it's just styrofoam. Um, but yeah, probably like 3 inches of that. So that's pretty solid, like R15 or so, maybe R16. Um, so yeah, so you want to cap that off. You want to find a way to insulate that. This is the same house. This is obviously an exterior wall. We have a window, and you look at the image here. So see if you can think about what's happening. So again, we know building framing, so we know what's going on up here. We should have a header right here. There's probably little tiny stud bays between these cripple studs, right? And they probably just didn't insulate it. So this home was built in the 50s, um, and insulation was not as big of a concern. Energy prices were not as high, and so they just skipped the insulation, and there were no codes to tell them if they had to do it. So this one's tricky to retrofit. You probably have to go outside and do blown in, like a dense pack, but that's tough because these bays aren't very big. The other thing is you could, I guess, cut the drywall and fill it in with insulation, maybe some spray foam, but that's quite a job, but that's probably the best way to do it. So this is actually a different house that has an unconditioned basement. And so here's the basement door. All right, so we're inside. Again, it's cold outside. And here's the basement door, which is unconditioned. Now we are running a blower door at this time, so we're depressurizing the house. All right, so we were sucking air out of the house. And so what's happening here is there's air being sucked in from the basement. You can see these streaks of cold air. That's cold air coming in from the basement. Okay. And so how do you fix that? You add a door sweep, right? So a door sweep, which goes on here, and it sort of is this, plastic or metal sort of flap that goes down here, and we'll cover that up and help prevent some of that um, heat loss. So this is interesting. Same house, that two-story house I was just talking about. Regular old windows still, and running the blower door. Um, but this is the IR image. So look what you see here. You see, again, more streaks. Okay. So there's some streaks coming out here. And so what's actually happening, believe it or not, that is just caulk that is missing, right? So there's a bead of caulk that they should put down there. I mean, that's like a nickel's worth of material and 2 minutes of your time. And that would fix that problem. So there's some really sneaky, again, this is some of that indirect leakage that's could be really hard, if not impossible, to pick up without an infrared camera. And so this is one of the values of an infrared camera. Here's a recessed light. Remember we talked about this earlier. Those can lights that are recessed up into the unconditioned attic space. So here again, you wouldn't have any idea anything's going on. Here's the infrared. I mean, it's just like, whoa, what's going on? With a black hole there. So this is really, really common to not have insulation. You can see streaks, so that's not sealed up either. And so you need to, you need to fix that. Now, what you can do for the streaks and the air leaks is you can just put spray foam around it. The other thing you can do is remember you can't put insulation on top of these non IC rated, right? Not insulation contact rated. So the cheap ones you can't put insulation on top of. But these are IC rated, so if you go down, if you go to, you can go to a regular hardware store and find these. In which case, if they're IC rated, you can put insulation right on top like that. If they're not IC rated, you do have options. Remember, you just need 3 inches on all sides. And so they make these caps that you can buy that look like this. There's just like these, it's got a cardboard type of cap, and you put it on top like that, and then you can fill the insulation on top of that. Or you can build your own box like this, and then fill the insulation on top of that. Okay. All right. So that ends this lesson on insulation and the use of an infrared camera. So hopefully you have a decent understanding of different types of insulation, how they, prevent heat loss and what they can be used for. Also, you should have a good understanding of how an infrared camera is valuable in terms of detecting missing insulation, detecting air leaks, along with the, if you're using a blower door, and some of the, you know, beneficial aspects of that. And then finally, with these ice, the recessed lights, it's important to understand that you can't put insulation on top unless it's rated for it. If it's not rated for it, you can either buy something or build something, and then put the insulation on top. But overall, all of this speaks to the value and the importance of having a complete thermal boundary. You have your air and thermal boundary and continuous contact with each other. And there's just every building's different, every house is different, and you encounter. I mean, I've been in dozens of houses and buildings, and like they're all different. And so it's really interesting to sort of figure out what's going on, where the inefficiencies are, and we usually do energy audits, and so we're figuring out how to improve the energy efficiency. Okay, anyway, those are all important considerations for insulation, and that ends this lesson.